Hello, stream. All right, today I want to talk about cases. So, cases are probably one of the most important aspects of our build, because it's literally how you're housing your device. Uh, so yeah, it's really kind of important. We should be taking a lot of consideration to what our case looks like and what our case does, and stuff like that. So, um, cases. All right, sorry. There we go. All right. So cases. Uh, Cases are extremely important to how we do and look at our computers. And for the most part, there's some type of square-ish object, although that doesn't have to be true anymore. Uh, they are some type of place that we can connect to uh, something that we can connect the motherboard to, that's housing the cooling system of it, that basically has all the items into it. And cases really matter because they kind of dictate how airflow works throughout the case. Uh, and I have a case here that I'm going to show off here in a second. And I have a couple other cases that in the future I'll be kind of showing off, even a special one that I was just able to buy recently. But specifically for the build, and the next week I'm actually going to be building out of this case. Well, this next week's stream will actually kind of consist of me building this computer that I've been kind of spending weeks talking about each piece of it. And that's this in H1 case. This is a Next H1. It is fairly small, fairly tiny, and it looks almost exactly like a Xbox Series X. Um, for size comparison, that's an Xbox Series X. Nice square little brick box. And when we look at the H1, it's only a little bit bigger than that. You can kind of see. So I just opened this up. I just opened it up. It is brand new. And I want to take a look at a little bit of it. And there's some things I want to talk about with it. But because I don't want to keep on holding it up all the time, what we're going to do is I'm going to bring up the manufacturer specs for a little bit. And then we can kind of take a look at that. So the Next H1 is what we consider an SFF case, small form factor, meaning that this whole thing is designed to be tiny. It is not meant to be huge. It's meant to take up less space. And as you saw, it is not much bigger than an Xbox Series X. Maybe double the size in volume. Yeah, so this is kind of one of the staple SFF cases that are out there. Although these are kind of limited, they only make so many of these every cycle. And they only come in two colors, but you can spray paint and change any type of color that you want out there. So the things about like this special case is that it has its own power supply built into it, and it has its own cooling built into it. So you don't need a lot of other items with it. You kind of just buy this case, slap a motherboard, slap a CPU and RAM, put a graphics card in there, and bam, you have a fully functioning computer. And that's actually what next week's going to be. We are going to kind of build this small form factor computer in probably less than 20 minutes, to be honest with you. We will take everything out of it, put in the motherboard, attach the RAM, the CPU, uh, not the graphics card right now. We'll attach all the pieces to it, and it will be fully functional before the night ends, before that stream ends. We will have a completely functional computer in probably less than half an hour or so. Yeah, so let's take a look a little bit more about what's special about this case here. Let's see if we can blow that picture up a little bit. There we go. So this is the standard format that it is. It's a cube. It's a black cube with open mesh on 3 sides. The top portion isn't necessarily open. It's a kind of a flat black. And then one side has the standard. See if I can find a picture of it. There we go. And it has the standard tempered glass look. You're going to find like a lot of computer cases nowadays have this standard tempered glass aspect to it. It's common nowadays, and because people want to see inside their cases. But as I've been talking about with this case here, we're not going to use the tempered glass. I actually have a specialized front cover that's going to come off of it. And now that's actually sitting up in here, sitting right next to the Xbox Series X, I might not end up spray painting it at all because it's going to end up looking very nice sitting side by side. And I'll let everyone see that once it's done and everything's in place on it. So I said a little bit ago that I bought another specialized case. And this one is almost as interesting. Let me see if I get in place here, then I'll toss it up on the screen here. So custom cases, you can do your own custom case occasionally, or you can get lucky enough and a manufacturer has made something custom. So this is a very limited edition, 500 units made by Next. And you're kind of seeing a theme of this year's cases for me. There are mostly Next cases. So this is an H510i limited edition Mass Effect case, going with their new their legendary edition of Mass Effect that's coming out this spring. So in the springtime, when about the time that the new legendary edition of Mass Effect comes out, I'm going to take this case here and redo my girlfriend's computer. And we'll kind of set it up to be very, very red and white. The case itself isn't black with a red stripe down it. Take a look at the image on the side here. When we set up the RAM and the coolers and everything like that, this will be a very, very black, red with white stripes on it case. And this is kind of a miniature version of my main computer. So, computer cases are extremely important with how they're actually laid out. And if they're not laid out correctly, well, guess what? Your whole computer is just going to stop working correctly. And today you get kind of Ryan drawing today. And I'm going to draw the issues that we have to think about with computers. So, as most of our computers that we have out there sit in type of some square case, and in that case you have some type of motherboard. So you have some type of motherboard that's on there. You have some type of graphics card that's in there. Some type of power supply that's in there. So those are the mostly where this location of these things sit. Let's put that graphics card a little bit higher up there. There we go. There we go. Power supply, graphics card. Those are our 3 main items. Now, we know the CPU is going to be sitting roughly about there, and the CPU is the biggest heat source of a computer. So proper airflow is really, really important here, and getting air away from wherever that CPU is sitting at. So the first question that always has to come into is, how are you cooling this? So if this was a liquid cooler, which is totally fine, it's a valid option, or if it's an air cooler, which is also a very valid option. The whole intent of that is to bring that heat off that CPU. So it's still sitting in that general area. Now, if you're using a cooler that has a water pipe that's bringing something over here to some type of water cooling system or liquid cooling system. All right. So air is going to come into our case. So our air's got to go somewhere. So we need some type of exhaust aspect. Why is that black pin thing not going away? So we need some type of exhaust aspect. So what is that? That is normally some type of fan there that's going to pull air out. And on your cheapest build out there, you're probably going to find just that. Uh, some type of, uh, if you have a liquid two fan systems, probably 280 millimeters. So probably 260 millimeters of fans. There's probably two there. 180 millimeter sitting back over there. And yeah, takes this cooler air, that really hot air that's sitting on top of the CPU, and it's going to push it out through that one exit port. And then, yeah, it works. It works. But you're going to notice that is probably not the best airflow movement that's out there. Um, you have this thing called static pressure versus negative pressure when it comes to case design. And there's a lot of arguments about which one is better depending on the case that you're doing. Do you want positive pressure going into your case? And positive pressure means that there is more air leaving than there is air coming in, meaning that you're pushing air into it and you're trying to fill the case up with air. So you're going to have, we can add airflow over here. And we're basically pushing as much air into the case as we possibly can so that there's a positive amount of air in the thing. And then we're having an exhaust port that's pushing air out. The other aspect is kind of thinking on the same lines, but we have more air going out than what's coming in. So we have some more exhaust built into this system. So we have air that's being pushed into the case, but at the same time, we are allowing more air to get sucked out. So the hot air is kind of being sucked away from the heat source. So that's kind of your negative system, negative because of the negative amount of air that's in the case, versus a positive system, there's more air in the case, more airflow. Uh, both are 100% usable. The big aspect of it is that you want air going through. So another portion that's actually creating air is your power supply. So your power supply is creating additional air. Your graphics card is creating additional air. And that's hot air, by the way. That's not even cold air. That's both of those are creating hot air rising up through the case. And you have this cooler air being pushed in. So hot air rises, cool air sinks. So the first thing the cool air is going to do is go down. It's going to get pushed upwards by the power supply and graphics card. So by the time you even get over there to the CPU and motherboard area, you already have air that's warmer coming in. So let's back this whole airflow up a little bit. And let's take this all the way back to not having a liquid cooling in there. Let's put ourselves a big old brick of a cooling system. And this time, let's draw in some more fans. All right. So this time I'm going to use red to talk about where hot air is coming from. So we have hot air coming there. We have hot air needing to be pushed out. And if you have a giant air cooler on top of it, it's creating hot air, pushing it away from there. And if we think of green as kind of our cool air. So we have this cool air coming in from the front side of the case. And another way that we could do this is doing something like this, where we have 3 that are pushing in cool air and then 2 that are taking out. And the goal of this is to kind of get this air to get pushed out towards these 2 exhaust fans. And that should kind of create a flow aspect of it where it's coming in and being pushed out through the exhaust. Okay. So basically, exhaust fans are really important. And one of the things that a lot of people tend to not even consider is like, what if I put the power supply upside down? Let's play that out here for a second. Okay. Let's say we put the power supply upside down and the power supply's fan is now facing towards the ground instead of going upwards into the case. All right. What's going to happen is you have all this hot air sitting right here. Okay. And it normally gets the intake from over here. So this is cool air coming down. All right. But hot air rises even if you're pushing it down. So you're forcing this hot air. You're going to force this hot air to kind of sit on top of itself, on the bottom of itself, which is going to heat up the material even more. It's not going to necessarily bring a lot of cool air down because this area in here is getting hot. So you're basically kind of bringing warm air into a hot air object. So you're just kind of adding hot air to hot air, which is going to cause issues for your power supply. And eventually it's just going to go flat. Because guess what? It just can't. You can only deal with so much hot air. So, okay, that's an issue. So definitely make sure your power supply is going in the right direction. I guess this would work better if I should have backed up. Okay. So we want that air coming out, heading up that way. All right. So NVIDIA has changed a little bit of the way graphics cards are pushing air now. And what they've done is reverse direction fans. And now they have a reverse direction fan sitting here and here. So you have this cooler air coming from the front and top. You have a little bit of this hot air coming up from the CPU, but it still should be overran by the cool air that's coming in through there. And now you have this cooler air coming in here, running across the card, being funneled out through the backside. So now you have hot air exiting this way, but if you have the appropriate amount of fans in there and you're distributing thing about airflow, this cool air is going to catch this warm air and blow it this direction. All right. So now it's kind of like, okay, you have this hot air and it's going across the CPU. Okay, that's an issue, right? Well, negligible issue. We're not talking a lot. So the heat pipes that are sitting on this air cooler is pulling the massive amount of heat away from there. So it's hot. It's hot already. And when you do ones like this, you tend to put fans on these. And this will add even more fans and forcibly take this air that's over here, which is this hotter air coming up from the graphics card, this cooler air coming from those fans there. It's going to push that through the graphics card, kind of a lukewarm one. But since it's nice and open and it's not being pressed on us like down over here on a power supply, that air is going to go directly into the exhaust and exit. So much more common to what you're actually going to see and what you want to see happen. You don't really want hot air just sitting inside your case. And you should be able to like put your hand up to the back of your case and feel air coming out of it. Any place where you have an exhaust set up, your hand should be able to go back there and feel whether or not there's actually any hot air coming from there. So this leads to kind of another issue. Dust and debris. So as your computer sits here and has all these moving fans, moving things out in the way, you're going to have dust and debris start settling in on your computer, especially in these exhaust areas. So this one here, this is going to get a lot of dust and debris. And in this scenario here, if I have an exhaust fan on top, there's going to be a lot of dust and debris sitting around over there. There's going to be a lot of dust and debris sitting there. And on this side. So basically anywhere where I have an intake or exhaust aspect of air flowing through there, I'm going to get dust, because you want dust on the outside. You do not want dust on the inside, which leads into like clean your damn cases. Pretty straightforward. People need to remember to clean their cases because this dust is building up. And if you get to the point in time where there's so much dust sitting on any one of these areas and it clogs, guess what? You no longer have proper air intake going into your case, which means now in this scenario down here, say that's all clogged. Now instead of having, I'm getting half the amount of air coming up in there, so it's less air, which means it's going to run hotter because it's not having enough cooling in there, which is going to cause more hot air to be pushed up into the rest of the case. Well, everything's just going to run hotter, and there is an upper limit to how hot things can get. Which leads to kind of an interesting little device that you really should think about purchasing. So when we think about all this, one of the things that I think a lot of people forget about is canned air. Canned air is fantastic. It does the job, and it really is the way that you should be doing things. But quite honestly, go buy yourself one of these instead. This is a Datavac electric duster. This costs about $45. You can buy this off Amazon and get it the next day. And in the long run of things, this is going to be significantly cheaper and safer for the environment, because this will last longer because you can plug this thing in. And it basically acts like a little leaf blower for your computer systems. And also runs significantly louder and more powerful than what your little air can is going to do, and it's just as safe. But it's also environmentally friendly because you're only buying one, and it's going to last you the rest of your life. Versus if you were to buy a can of air and sit there, it's only going to last you 3, maybe 4 times of spraying your keyboard out and your computer out before it goes bad. There goes into that whole thing of heat distribution. You want to get rid of the dust, you need canned air, go buy yourself a Datavac. It is it's so worth it. Safer for the environment than those canned airs. Cheaper for your wallet in the long run. $45, you can buy this, it'll last you the rest of your life. So let's talk about the H1 and how that is situated. So let me get my own reference picture up here. So the H1 is smaller. It's meant to kind of uh, be this smaller computer. So we have to be more aware of where everything is sitting at inside this case. Um, and like I said earlier, the entire case is open, basically, because you have four sides of. Kind of take a look at it here real quick again. One tempered glass, um, left side, right side, back side, all has this mesh aspect to it, and even the bottom's open on it. So really, the only sides that's closed off is the very, very top where the power supply is sitting, and then the tempered glass, because you want to, because everybody loves that tempered glass. As I said, I'm going to take this tempered glass off and putting a special one that's going to add more airflow capabilities coming into this. So this type of case doesn't have fans, doesn't have a lot of fans. But what it does have is some type of liquid cooler aspect to it. So let's see if I can see an internal picture. There we go. So you'll kind of notice here's the back side of it, and there's the liquid cooler, which means there's the motherboard. There's the motherboard. There's the power supply. So where would the graphics card sit on this thing? So if we take a look here, you see this little bay right here on the side. So this square off space is where the motherboard will sit. We're going to have a special little extension thing to be able to bring it around. The graphics card is going to sit right here, and then our liquid cooler is going to sit right back in there. So if we go back to our drawing tablet here for a second, so we have our square. So let's draw this out a second. So there's the bottom. This is where cables are going to sit at. All right. Over here is going to be our power supply. And right about here, let's make that green to match what we were doing before. So there's our fan. There's our fan plus our liquid reservoir with cables coming over here. There's where the CPU is going to be sitting at. So we have lots of open, not necessarily a lot of open space, but we have space, meaning that there's a little bit of room in this case for things to get a little bit larger, a little bit smaller. But for the most part, what you're going to see happen in this type of situation is here comes the airflow. Remember, so this was liquid cooling, so it's going to pull that air off of here back to this reservoir where the fan's at. It's going to cool that down. The hot air is just going to go straight through. And since this is all open, this is going to leave. Pretty straightforward design, okay? I just noticed there's actually that bay there. And your graphics card will sit somewhere right about there. So again, and it's just pushing on through. Pretty simple. Now there's not a lot of room in this case to add more fans to distribute that heat. There just isn't. What you'll see people do is take that case. So let's build it up just a little bit better this time. So that's our graphics card, our motherboard. There's our cooler, with our fan. Okay. So what we'll see people do is on the back side of the case where the graphics card is, we will add more fans pushing in additional air. This will kind of help get some more positive airflow into the case and cool things down. Now, realistically, you shouldn't have that much heat being built up into this. It will be hot, especially if you're running a really high. If you're running like a i9, a 9000 or 10000 series, or an AMD 3950X, 3900 XT, yes, those are going to get really, really hot. And that's where the liquid cooling is really going to come into play, and you really got to worry about just cooling down that exhaust. That'll keep the chip down. Other chips, like the one I'm going to initially put in here, this is going to be a 3200G. It's not going to get that hot. It's just not going to be capable of getting those super, super high temperatures. Now, I am going to swap this over to a 3950X here over the next couple of months, as this is going to, my original idea was this is going to be a secondary streaming machine. That has now changed. This is going to become a mini home storage server. I will be adding in a special array and add in more solid state drives into this one to kind of build a centralized home storage hub. But I'll do that over the next couple of months. So yeah. Are there bad cases? Yes. there are some like horribly bad cases that you can go and purchase. And I mean like things that just are garbage. Because if you're not taking into consideration your airflow and making sure that everything can breathe, if you put a chip in there that's very, very power hungry, and it creates a lot of higher temperatures, your case isn't going to handle it well. It's not going to breathe very well. It's going to get hot. And there is a certain point where your CPU is just going to shut itself down, because that's what CPUs are meant to do. As you sit there and you are using it, a CPU will know when it's too hot, and it'll shut itself down, and it will allow you to use it until it cools itself off. So a bad case will just feed into that, and you'll know it because you can be able to put a temperature checker on it. Watch your temperatures, and they'll just max out. You'll see 100 degrees, 120 degrees, and if you're getting that hot on there, you are literally going to do damage to the internals of your CPU, and the whole thing is just going to go black. And it happens. It happens all the time. It's common. That's a common mistake people tend to make their very first time. They don't take in airflow, or they attach their fans in the wrong direction. Imagine going back to that design of that full ATX build, and you started pushing all the air out, and there was nothing bringing in. In that case, none of the air is. I mean, yeah, you're just hot air. There's no cool air coming in to offset the warm air that's going on. So yeah, air pressure cooling is really important. And when you do something small form factor and you're building tiny, airflow matters even more, because you have to worry about those things a little bit more. There's not a lot of room to play around with things. And yeah, it is what it is. You're more likely to have some burnout. Uh, Everything is just going to read hot all the time. But you can also build full scale, high end gaming machines in small form factor uh, that will look just gorgeous and minimalistic with your own internal builds. Uh, just put a lot of thought into it and make sure you're building for what you're actually trying to build for. Yeah. So that's all I really talk about cases, but I'm gonna talk about one other thing interesting. So I was lucky enough that I was able to get a 3900X. Sorry, an RTX 3900. But I already had to send it back to RMA. So we had it for about 20 minutes was the amount of time from the time they dropped it off. Walked upstairs, connected it into my main computer, and it didn't. Well, it worked, but there was an obvious issue with it. And give me a second here, and I will play a video of what happened. Let me jump it over here on this screen. And then let me put desktop audio on. Okay. So that did not. Why are you not? So what you can't. I'm hoping it's coming across there. It was clicking. The fans on here clicked, and it wasn't a smooth run. So when we put it into the computer and ran it for the first time, uh, noticeably you couldn't use it, because if you're actually going to put this onto a full load, we didn't even let it do a full startup because it was just clicking. Click, 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 click. Now imagine that hitting like a couple hundred or a couple thousand revolutions. It would have done massive damage to the card. So hopefully in December, because it's going to take a couple weeks, 5 days back, 5 days there, 5 days back to me. We're probably looking at 15 days before I get a replacement for it. So maybe sometime in December, I'll be able to show off a 3090 and talk about its capabilities and what to expect and not to expect out of that. But that's kind of it for tonight. I hope everybody has a good night, and talk to you later. Bye.